I am the Philosophical Bachelor, and today I want to talk about Originary Space. In a previous essay entitled The Nothing, I theorized that the universe may have originated from the nothing, which is a void. I brought up higher dimensions to try to save the notion that the void may have nothing, but it has space. The reason why I needed it to have space is because space is needed to get from the nothing to something. That is because quantum fields are characteristic of space, and my theory needs them to generate virtual particles, some of which can then become actual particles that lead finally to a universe of things. On further reflection, I created an unnecessarily complicated solution, though if indeed it is later confirmed that there are indeed higher dimensions, my solution involving higher dimensions would then be more general. I want to revisit what I called my special solution, which is only the usual 4 dimensions of space-time, putting aside higher dimensions since they may cause unnecessary confusion. The reason why I trouble over the ontology of space is because since the advent of general relativity, the notion of absolute space seems threatened, even though it is not clear that Albert Einstein himself was against absolute space. There are even solutions to his equations where there are multiple distinct spacetimes with different geometry compatible with a completely empty universe, according to an article by Dan Peterson, a specialist in the philosophy of physics. The issue arises because when working backwards using Einstein's field equations to the start of everything, we end up with a singularity, where all mass energy is compressed into a hyper-dense, hyper-tiny point. Space-time, which takes its geometry from matter according to relativity, in turn becomes so tightly curved by this infinite density that it also becomes point-like. In addition, with the paradigm of Leibnizian relative space-time, we seem to be left with a paradox where if there is no mass energy, then there is no space-time, though, as mentioned, Einstein's field equations have compatible vacuum solutions. This problem does not arise if there has always been mass energy in the universe. That means that the void is a useless hypothesis since it never existed. Space was never empty, making the nothing truly nothing, non-existent in the history of the universe. In that case, whatever the geometry of space-time happens to be, the prevalence of space-time is never threatened since relative space-time always exists given the always existent mass energy. Creatio ex nihilo is then, along with the void, a useless hypothesis since the situation is one of creatio ex materia, true and true. Relative space-time suggests that if there is no mass energy, there is no space-time. Space-time is only meaningful as a concept if there is mass energy for space-time to be in relation to. Hence, however they arise, they must have both arisen simultaneously. If all mass energy can somehow be removed, space-time will correspondingly vanish. Such a situation is, however, impossible to create empirically, and so such a consequence cannot be demonstrated. Besides, we do not know what a lack of space-time will even look like, since space and time are invisible and have no weight or any measurable quantity, since measurement presupposes their existence. What I want to suggest is this. Space-time exists originally. At first, the universe was a void, an infinite absolute space-time matrix with no physical content. The geometry of this space-time is undeformed, since there is no mass energy to deform it. Hence, it is a matrix linear in each of its 4 dimensions. When completely unperturbed and totally stable, a state which may exist only fleetingly, if at all, in the void, any fields in it is at every point at a value of 0. Heisenberg's uncertainty principle tells us that we cannot know both the position and momentum of any quantum particle with certainty at the same time. We also cannot, in a short interval of time, know the amount of energy in a space. In the void, there will for the most part be no particles and no energy. However, there can arise momentarily deviations from zero in the fields of the void, in keeping with Heisenberg's uncertainty principle. But first, we should clarify what a field is. A field is a continuous manifold in space, where each point in this manifold has a value for what it is a field of. It can be a field of anything, say a field of strawberries. At each point of the space-time manifold of the void, the number of strawberries is zero. There are no strawberries there. What we are doing by referring to quantum fields in the void is similar to saying that the field of strawberries in the void has a value of 0 strawberries at each point of the field. However, is it legitimate in the case of zero quantity at all points to even speak of a field? We might as well talk about how there are empty potato fields, fields of cars, pencils, etc. in the void. All such fields can technically be said to exist in the void, but with each point having a value of 0 strawberries, potatoes, cars, or pencils. It is not such a stretch if you consider how one may say that there are no or 0 keys, money, books, monkeys, or dinosaurs in one's bag. The first 3 examples are not so odd for a bag to not contain, but the last 2 are also correct to say, even if it may be strange. In any case, points in the fields in the void may momentarily deviate from a 0 value. These deviations or fluctuations of the field may give rise to pairs of virtual particles and antiparticles, which usually would be attracted to each other and mutually annihilate upon contact, returning the points in the field to 0 value. Mass energy is hence conserved, though in that brief moment when they arise, they seem to have borrowed the energy from the void, which they pay back upon annihilation. However, not all pairs of virtual particles annihilate, with some becoming actual particles and antiparticles. In my metaphysical investigations essay, I have proposed 2 potential mechanisms by which virtual particles can become actual particles through separation while still obeying mass energy conservation. They are 1. A wall of virtual particles springing up between the components of an earlier pair, separating them permanently. 2. A reaction between components of different pairs leading to new compound particles. They are unreactive with the original components. These virtual and actual particles will not be as large as strawberries or cars, but are the fundamental particles in the standard model of particle physics, such as fermions and bosons. From these actual particles, the primordial universe is on its way to becoming a universe of things, as they gather to form increasingly heavy and larger objects. Yet the story of the known universe is not as I have told. The empirical account is of a Big Bang 14 billion years ago. So my account is only part of the story. The early actual particles continue forming out of virtual particles via the mechanisms. These fundamental particles consolidate to progressively become protons, neutrons, atoms, molecules, stars, planets, galaxies, and so on. The mass energy in the universe becoming more and more heavy until they collapse on themselves, which will be our first big crunch, where all the masses and energy get compressed into a hyper-dense, hyper-tiny space of a singularity. During this big crunch, the increasing density of mass energy also caused space-time to become increasingly curved, finally becoming so tightly curved that it along with the mass energy forms a singularity in keeping with the predictions of general relativity. It then rebounds to give the Big Bang, where in its cosmic inflation, mass energy is thrown outwards, along with the unfolding of space-time. In conclusion, in order to hypothesize a creatio ex nihilo account of the origin of the universe, I posit that the universe was at first a void which has space-time. Fluctuations in the void, in line with Heisenberg's uncertainty principle, led to the formation of virtual particles, some of which became actual particles, leading to a universe of things. As this universe of things become increasingly massive, it leads to a collapse, a big crunch, which results in a singularity, where all mass energy gets compressed into a hyperdense point. Since mass energy deforms space-time, this hyperdense mass energy likewise causes space-time to curve so tightly that it, along with its content, forms a singularity. This singularity then becomes unstable, resulting in the Big Bang, where in its cosmic inflation, mass energy gets dispersed and space-time correspondingly unfolds. Thank you for listening to the Philosophical Bachelor.